Hey everyone, welcome back. In our last video, we learned how to design our graduation medallion here. Well, in this video, we are going to learn how to manufacture our graduation medallion out of a block of brass 360. And brass 360 is a very common type of brass used in manufacturing. It's actually a mixture of copper, zinc, and a little bit of lead, which makes it a bit softer and easy to machine. So let's go ahead and get started. The first thing you want to do is to change your workspace now from design to manufacture. So the first thing we want to do, just like we always do when we start manufacturing something, is start a new setup. So we're going to come on up here and we're going to do a new setup. Okay. And we're going to go ahead now and select our origin as stock box point. Okay. And what we want to do is we want to orientate it so that it looks something like this. Okay. All right. And now we're going to select this back left corner here. Okay. So we want to make sure now that our X is going left to right here, and our Y is going away from us, and our Z is pointing upwards. Okay, so we need to change a few things here. So let's come on over here and let's go ahead and select our, well, let's just select our Z and Y axes here. So it's asking us here for our Z axis. Well, our Z axis, we want it to go vertically, so up and down. So that line will work. Okay, and now it wants us to select our y-axis. So we need to find a feature here or a line that is in the y direction. And it looks like this construction line here will work. So I'm going to click on that construction line, and notice now it moved our our work coordinate system over to this corner. So we got to go back and change that now. Okay, so let's come on over here and go to model box and then back to stock box. And now let's click on that back left point, and our X is in the wrong direction. So we need to flip that guy. So let's go ahead now. And actually our Y is in the wrong direction too. So let's just go ahead and check that guy. Check that left corner again and we're good. Okay. Sometimes it's easy and it pops up, and sometimes it's not always straightforward. So we need to go in and change some things here. But when you're all done, your work coordinate system, your G54, should be in the back left corner for our reference point, our work coordinate system. Make sure our positive Y is pointing away from us, our positive X is going to our right, and our positive Z is pointing upwards. Okay. Once you've got that, let's come on over here now to our stock size, and we're going to go to fixed size box. So for our Y here, excuse me, for our X here, we want to set that to 3.4 inches. So when you go to cut your stock in our saw, you want to cut it to 3.4 inches. Okay. Our depth here is 3 inches. So set that to 3. And our height, or Z, is not 0.5, it's 3/8. So we're going to set that to 0.375 or 3/8. Okay, and we don't want to center it. We want it offset from positive Z here, a distance of 0.02. Okay, and that should do it for our first setup. I'm going to go ahead and hit OK. I'm actually going to rename this as just setup 1. Okay, and I would go ahead and save this. Okay, since you got your first setup already good to go. So the first thing we want to do is a 2D facing operation. And a facing operation is used to basically get a perfectly flat machined part, as well as to remove that oxidized surface along the top of our metal. So let's come on up here to 2D face, and we're going to select our tool. We're going to come over here to the Medallion tool library. Okay, and to get your tool library, just come on over here to local and right click import tool libraries, but we already have it imported. So in this case, click on Medallion tool library, and we're going to select our 2.5-inch face mill. So let's go ahead and select that guy, set our coolant to flood. All right, and we're going to set our spindle speed now to 4,000. Okay, and we are going to set our feed rate now to 20. And I'm going to hit the tab button now, and I'm just going to tab down. Let's do 20 there, 20 there, and we're going to do 10 for our ramp and 10 for our plunge. Okay, and then for our geometry, we want to select the entire part here. So we're going to select that guy right there so that this red line is selected, or yellow line. Okay. And then we're going to come on over to our passes tab, and we're going to set our pass extension to 1 inch. So that'll basically send our tool out farther from our part and give us ample time to stop the machine in case something doesn't look right. Okay. And then for our stock offset, that's going to widen our tool path. We're going to set that to 0.5 inches. So that's going to widen our tool path 0.5 inches. Everything else, all the other default values look good. Let's go ahead and select OK. Okay, and there you go. Remember, you should be simulating every single operation after you're done just to make sure it looks right. Okay, we'll go ahead and simulate the entire operation at the end of our first setup. But for now, let's go ahead and start our next 2D toolpath here. So what we're going to do now is we are going to engrave our text here. So all of the stuff that you see here, your text, your logo, we're going to go ahead and engrave that. We're going to go to 2D, and we're going to start a tracing operation here. All right, and now we need to specify our tool. We're not going to be using a face mill to trace, obviously. So let's come over to Medallion tool library, and we are going to select our 6.25 millimeter chamfer tool. And this is a very fine tipped point tool that we're going to use to engrave everything, our logo, our text, and all that good stuff. So go ahead and select your 6.25 millimeter chamfer tool there. So let's go ahead and select that guy. Our coolant, let's select flood. And for our RPMs, we are going to select, or excuse me, yeah, for our spindle speed, 3000 RPMs and a cutting feed rate now of 20 inches per minute. Okay. All of our other default values are fine. Now for our geometry tool, now here's where things get interesting. You've got to click on everything that you want to engrave. So that, okay, this circle right here, our decorative pattern here. I'm going to zoom in, and then you got to start clicking on your logo stuff as well too. And this can be tedious, so be careful, and you might miss something. So click on your R's, your letters. It would help to zoom in too, I recommend. So I'm going to go ahead and speed the video up now while you guys click on all of your text and logo here. And when you're done, double check to make sure you got everything, okay? Because it's easy to miss a little line or something, okay? And once you got all that, go ahead and now let's come on over to the passes tab. So now we need to specify how deep we want to engrave our text and our logo. So we can do that here under axial offset. So what we're going to do is we're going to set our axial offset to minus 0.05, and that's deeper than most cuts because for this particular operation we are using a spring-loaded engraving tool. So it's got a spring in it, so there's some give. So normally we would probably set it to something like minus 0.01, okay? But with a spring-loaded engraving tool, we're gonna set our depth a little bit deeper, our engraving depth to minus 0.05. Okay, check smoothing and hit OK. So real quick, let's go ahead now and simulate this guy because this is a big very long operation. And you're going to notice that when you go to actually simulate it, okay, it engraves very deep and your cuts are really, well, not very detailed, right? So let's pause this real quick. I'm going to close this. Let's come back into our trace, edit it, and let's come on back and set this guy to 0.01 because I just want to show you. 0.01 and hit OK. You're going to get the same toolpath. Let's simulate it. And what it's going to really look like is probably something like this. Okay. So you can see the difference here. It's not cutting nearly as deep. Okay. So we got to change that though because we do need to set it to, let's edit it. We do need to set it to a minus 0.05 inches. Okay. All right, now that our tracing operation is done, we can start removing material along the perimeter of our medallion. So let's go ahead now and start a 2D adaptive clearing operation here. So we're going to change our tool now. We're going to come into a medallion tool library and we're going to select our 1/2 inch 3-flute end mill here. So our 1/2 inch end mill. Select that guy. Okay, our coolant is set to flood. We're going to set our spindle speed now to 5,000 RPMs. And we're going to use a feed rate now of 30 inches per minute. Okay, all of our other default values are fine. Let's come over here now to our geometry tab. And we're going to go ahead and select, let's see here, this bottom exterior contour here. And for our passes tab, all right, we want to set our optimal load to 0.1. So about a step over of about 0.1 so that about 20% of our tool is engaged with our part. Okay, and then for stock to leave, we're going to leave a smaller amount this time, 0.01. Okay, and then let's go ahead and check smoothing to simplify our G-code and select feed optimization so that it slows down our tool when our tool's in these corners right here. So we reduce tool wear and tool breakage. Okay, so when you're done with that, go ahead and select OK, and you should hopefully get the following toolpath. All right, so after you've simulated your 2D adaptive, now let's go ahead and start our next operation. And for the next operation, we need to hollow this area out, this little small pocket here of our medallion so we can hang it, right? So we need to come on up here. We're going to select a 2D pocket operation, and we're going to change our tool now. And that's a very small sort of pocket, right? So we need to use a smaller tool. And we're going to come in, we're going to select our 1/8 end mill here. And this 1/8 end mill has a wider shank, so it's a very strong. It's very strong for a 1/8 end mill, so it shouldn't break easily. But nonetheless, we're still going to take precautions. Let's go ahead now and select our 1/8, and it's a 2-flute end mill. And we're using a 2-flute because it's a very small pocket. We want to use less cutting teeth or flutes, so we allow for more chip evacuation. Okay, so we're going to go ahead and select that tool. We are going to set our spindle speed now at 5,000. Okay, our ramp spindle speed also to 5,000. And our cutting feed rate, we're going to set to 10. I'm going to use the tab button now, and I'm just going to set my ramp feed rate to 10 as well as my plunge feed rate to 10. Okay. And now for our geometry, we have to select the bottom here of our small little pocket, or almost a hole here. Okay. And then we're going to come on over now to passes. We're going to set our maximum step over here to 0.03. Okay, and we are now going to sort of leave some varying stock along our radial or walls of our part and floors of our part. So for our radial stock to leave, okay, we want to leave 0.01 inches. And then for our axial stock along the floor, we're going to just leave 0. We're going to go all the way down here. Okay. Okay, and then we're going to go ahead and check smoothing, and then for our linking tab, our ramp type, we're going to use the default setting of helix, and we're going to change the angle though to 3. Okay, and then we are going to hit OK. And if you zoom in and you take a look here, you can see the actual toolpath here. Make sure you simulate it, please. All right, so that does it for our roughing operations. Now let's come through and remove the stock that we left on the inside here and along the outer edge or perimeter of our medallion. So let's come on up to 2D, and we're going to select a 2D contour. Okay, we're going to use the same tool, that 1/8 end mill. Okay, we're going to set our coolant to flood. We're going to use a spindle speed though. You know, if with finishing operations, we typically use slower spindle speeds and feed rates. So we're going to set that guy to 3,000 and our cutting feed rate to 20. Okay, all the other default values are good. For our geometry, if you recall, we left some stock along these walls, so we're going to select the bottom here, and then we left some stock along the perimeter outer edges of our part, so we're going to select that line right there. Okay, and then for our passes tab, all of our default values are good. Go ahead and select OK. So we're pretty much done now. We just need to do one more thing, and that's deburr the outer edges of our medallion. So we're going to come on up here and we're going to do another 2D contour toolpath, but this time we're going to change our tool now, and we are going to come to our medallion tool library and we are going to select our 1/4 inch chamfer tool. Okay, so let's select that guy, set your coolant to flood. We're going to use a spindle speed of 3,000 and a cutting feed rate of 20 inches per minute. Okay, and for our geometry tab now, we want to deburr this edge right here and this outer edge right here. Okay, then for our passes tab, okay, this is important. Make sure the chamfer box is checked. We're going to set our chamfer width to 0.01. So we're going to leave a really small chamfer on there. Okay, and we're going to offset the tip a little bit from the edge, a distance of 0.02. Okay. Okay, all the other default values are good. Let's go ahead and select OK. When you're done with the entire operation, okay, go ahead and simulate your first setup. So I'm going to go ahead now and click on setup, right click, and let's go ahead and simulate that guy. Let's show your stock, okay, and check stock on collision, and let's go ahead and hit play. Okay, and I'm going to speed it up a little bit just for time purposes. So there is our facing operation, all right, and there is our engraving operation. And here is our 2D adaptive clearing, our roughing operation, okay, and then our pocket, and then our finishing passes along the outer edge, and then our deburring pass. And when you're done, you should have a total machining time right around of 11 minutes, okay? Obviously, yours is going to be a little bit different depending upon what text you engraved here, okay? So that'll do it for our first setup for our medallion. All right, so go ahead and stay tuned for our next video where we machine our second setup. All right, thank you so much for watching, and we'll see you next time.